The holidays are a time for giving, but today we're celebrating the gifts we've already received. But actually, these gifts didn't come from old Saint Nick, but by remarkable women whose brilliance, creativity, and courage shaped our world. From scientists unlocking the secrets of our universe to musicians who pioneered rock and roll, each of these women left behind a gift that still echoes through our world today. Let's get to the presents. Our first gift from Gladys West. Let's see what she so generously left for us. GPS, just what we needed. The power to find your way anywhere on Earth. Gladys was a mathematician who helped model the exact shape of the Earth. Working quietly in a US Navy lab, her calculations became the foundation for GPS technology. Yet for decades, credit went elsewhere. Today, we're finally giving her the spotlight she deserves. GPS, Global Positioning System, an invention that changed the world. You use it every day. Your phone, your car, even planes and rockets depend on it. The National Inventors Hall of Fame credits 3 men with creating the technology. But actually, the foundation for GPS wasn't built by any of them. The person who did, Gladys Mae West. And if it wasn't for a college alumni event and some fiercely loyal sorority sisters, she may never have received the credit she deserved. Gladys was born in 1930, the daughter of sharecroppers raised on a small farm where she picked corn, cotton, and tobacco. But even as a child, she dreamt of more.
I told myself that I did not like being out in the sun and working from sunrise to sunset and all that. So I made good grades in all of my subjects.
So she worked relentlessly, graduated valedictorian of her high school, and earned a full scholarship to Virginia State College. Something almost unheard of for a Black woman in the segregated South. And that scholarship would set her on a path from a farm in Sutherland, Virginia, to a government lab where she would create a map of the Earth so groundbreaking, it would change the way we navigate the world. It took until 1956 for Gladys to finally land the government position she had dreamed of, at the Naval Weapons Lab. Her role started like most women mathematicians of her time, doing endless calculations by hand. Just like Katherine Johnson over at NASA, she was a human computer. But then came a turning point. The lab installed one of the most powerful computers of the era, the Naval Ordnance Research Calculator. Gladys quickly mastered the machine. Her first assignment? Chart the motion of Pluto in relation to Neptune. That required 5 billion arithmetic calculations, 100 hours of nonstop computer time. And Gladys programmed every step. Her next project, tracking satellite orbits. Remember, this was the 1960s. The space race was on. America was desperate not to fall behind the Soviet Union. And there was Gladys, crunching the math that satellites and the future would depend on.
My part in the global positioning system would be working more with the orbit over the water. A lot goes into the scientific computation to generate an orbit, which is a database used in GPS.
By the late 1970s, Gladys's focus shifted from space to Earth. In 1978, NASA launched the first Earth-orbiting satellite designed to study the oceans. Gladys was put in charge. Her mission? Use the satellite's data to measure ocean depths, to then create highly accurate computer simulations of the Earth's entire surface. The results were astonishing. Gladys and her team built one of the most accurate simulations of the planet ever created. A decade later, 1986, Gladys published a guide showing her data could do something even more than simulate the ocean floor. They could calculate a geoid. A geoid is a mathematical model of the Earth's shape. Not a perfect sphere, but the real lumpy, tilted, gravity-warped Earth. Her algorithms took into account tidal forces, gravitational pulls, and even tiny distortions across the globe. The result? A model of the Earth so precise, it was unlike anything previously produced. It became the essential building block of the modern GPS satellite orbit. So every time your phone reroutes you around traffic, it's leaning on the math that Gladys Mae West once ran through a military computer in the 1980s. Here's where Gladys's story takes a turn for the worse. As time went on, it seemed like credit for the global positioning system went to anyone but Gladys. In 2002, the Hall of Fame inducted Ivan Getting, a physicist who championed the concept of satellite navigation, and Bradford Parkinson, an Air Force colonel often called the father of GPS. Then, in 2010, they added Roger Easton, who developed GPS satellite timing and tracking concepts. All three men made real contributions to modern GPS technology, but they were all building on Gladys's foundation. It was her Earth model that made the entire system possible. Then, everything changed. In 2017, Gladys submitted a short biography for an alumni event to her college sorority, Alpha Kappa Alpha. In it, she casually mentioned her role in developing GPS. Her sorority sisters were floored. They immediately contacted the Associated Press. Never underestimate the power of sisterhood. By 2018, the AP had published her story. The US military officially called her a hidden figure of GPS. She was inducted into the Air Force Space and Missile Pioneers Hall of Fame, where she was recognized for building, quote, what ultimately became the Global Positioning System orbit. And finally, after decades in obscurity, Gladys Mae West was recognized as one of the essential minds behind the system guiding the modern world. But the National Inventors Hall of Fame? Well, Gladys is still waiting for the credit she deserves. Today, the world uses GPS for everything, calling a rideshare, tracking a delivery, navigating a battlefield, even swiping on dating apps. Or literally driving anywhere in my car.
I never would have thought that I could sit in a car and, it says, turn left, turn right. No.
Every single one of those pins drop on Gladys Mae West's math. And yet for most of her life, her name was erased from the narrative. So next time your phone says, you've arrived at your destination, remember the woman who mapped the world so precisely the satellites could follow. Thank you, Gladys Mae West, for defying every barrier and proving that one woman's intellect could guide the whole world. Thanks for the gift of GPS, Gladys. Next up, a gift from Abby Aldrich Rockefeller, Lily P. Bliss, and Mary Quinn Sullivan. An iconic gift of modern art in the Big Apple, MoMA. Abby, Lily, and Mary founded the Museum of Modern Art when abstract art was still considered radical and widely misunderstood. Their belief in the modern movement changed the trajectory of American art. Yet, when the media started celebrating MoMA's success, Abby, Lily, and Mary were nowhere to be found in the headlines. Instead, all the credit was handed to a man running the museum they had built. 1920s New York. In the art world, respected museums were houses of history. From New York to London, revered art was synonymous with tradition, representational, realist portraits and landscapes, while beneath the cultural surface, more experimental art was becoming all the rage. If you wanted to see something fresh in the US, something boundary-pushing, good luck finding it in a prestigious museum. They didn't want to waste precious wall space on abstracted lines and splatters. But this is where our leading ladies come in. 3 women with disruptive ideas and the means to make things happen. First up, Lily P. Bliss. She's old money and heir to her father's textile business, an art lover with razor-sharp instincts. The kind of woman who collected pieces that, at the time, people thought were outrageous, like, oh, sweetie, a Matisse? Really? Next up, Abby Aldrich Rockefeller. Yes, those Rockefellers. Funny enough, her husband hated modern art, didn't take it seriously. So, as one does when fueled by intuition, Abby set off to fundraise on her own and buy up the most controversial art of the time. And finally, Mary Quinn Sullivan, the art teacher, a pioneering collector who devoted her life to art from an early age. Growing up, she went to public school in Indianapolis and learned how to get things done. Now, these 3 ladies each collected art on their own. Early on, Lily snatched up many iconic works like Van Gogh's Starry Night that would later become some of MoMA's core pieces. Lily, Abby, and Mary had fallen in love with the new, the bold, stuff that makes you think differently. And they wanted the world to fall in love too. So when they saw that real museums around them were slow to embrace these new perspectives as art, they realized they had the money and connections to shake things up. Their idea for the Museum of Modern Art was born over lunch in 1928. Let's fast forward through a year full of prep work to October 1929. The infamous Wall Street crash triggered a decade-long global economic turndown. Millions are losing their jobs and families are struggling to put food on the table. And days later, November 1929, our leading ladies decide now's the time to open the Museum of Modern Art. That sounds, well, quite insane. But they knew the time was right because people needed something new. Something that could give a glimpse into forward-thinking possibilities and a place where creativity could offer an escape from reality. MoMA first opened in a rented space on the corner of 5th Avenue and 75th Street, only a few blocks away from where the museum is today. Its first exhibit, titled Cézanne Gauguin Seurat Van Gogh, was a massive hit. More than 47,000 people visited during its 1-month run, and the critics gave rave reviews. But many of those rave reviews failed to credit Lily, Abby, or Mary. Instead, they praised Alfred H. Barr Jr., the man who had been appointed as the museum's director only after the daring ladies incepted, funded, and built it. Alfred was very smart and had incredible vision. His programming made MoMA what it is today, including how the museum features all types of art like painting, photography, architecture, and film, and that is so important. But he didn't actually start it. He was brought on to run an already fully funded, fully operational museum by 3 women, and yet for years, his name was primarily credited with MoMA's creation. One book, titled The Biography of its Founder, Alfred Barr, blatantly mislabeled him as the founder, and another, titled Alfred H. Barr Jr. and the Intellectual Origins of the Museum of Modern Art, credits him as the initial idea guy. No one even thought to take a picture of the 3 women together. One might assume there would be a photo of the co-founders of one of the world's most influential institutions. But at the time, people didn't think they were important enough. Today, we love to celebrate our leading ladies. From the moment MoMA opened its doors, the art world was forever changed. It redefined what a museum could be. And that's all thanks to the ideas and follow-through of Lily Pete Bliss, Abby Aldrich Rockefeller, and Mary Quinn Sullivan. Their legacy goes beyond merely shaping the trajectory of our history, as many of the pieces from their personal art collections still hang in MoMA's galleries today. Next time you're in the Big Apple and stop by the iconic Museum of Modern Art, look for these works from their personal collections: Duchamp's Bicycle Wheel, Seurat's Evening Henfleur, Picasso's Les Demoiselles d'Avignon, and more. Thank you, Lily, Abby, and Mary, for your exquisite taste and willingness to take risks. You actually started a museum that rewrote the rules. Thanks for MoMA, Lily, Abby, and Mary. I can see why they call you the Daring Ladies. Let's get to the next gift. This one is from Vera Rubin. Let's see. A galaxy, or at least understanding what they're made of. Vera Rubin studied how stars and solar systems move through galaxies and found something astonishing. Her work provided overwhelming evidence for the existence of dark matter, the invisible substance that holds galaxies together and makes up most of the universe. But when dark matter became the hottest topic in astrophysics, Vera didn't get the credit she deserved. Let's rewind. Vera Rubin was born in Philadelphia in 1928. When she was 10 years old, her family moved to Washington, D.C., where she built her first telescope with the help of her father, using cardboard tubes and old lenses. By 12, she preferred stargazing over sleeping, mapping the stars and watching meteor showers from her bedroom window. Her father was an electrical engineer and amateur astronomer himself, and supported her curiosity. Yet, as Vera later recalled in interviews, there were no female astronomers for her to look up to. But she knew astronomy was her calling. When it came time to go to college, most university astronomy departments simply didn't admit women. But Vassar College was an exception. That's where she earned her undergraduate degree, and she was the only astronomy student in the entire program. She went on to get her master's at Cornell in 1951. Her master's thesis challenged the accepted Big Bang theory by proposing galaxies weren't just expanding, they were rotating around an unknown center. And the response? A polite, unanimous rejection from the American Astronomical Society. Of course, her little theory is now accepted as fact. Vera also discovered the supergalactic plane, a structure that connects galaxies like an intergalactic equator. But since the AAS was busy ignoring her thesis, this discovery went uncredited until later, when it was attributed to a different male astronomer who independently discovered it years later. While completing her PhD at Georgetown University, Vera discovered that galaxies were not randomly distributed in the universe, but instead had a tendency to actually cluster together, suggesting for the first time the presence of large-scale cosmic structures. She was right, but of course the scientific community ignored this too. You'd think after so many discoveries, before she even completed her PhD, that Vera had an easy time at school. But she, nor any female students at Georgetown, were even allowed to go inside the academic offices. So, she would meet her thesis advisor in the lobby. Vera's big break came when she joined the Carnegie Institution's Department of Terrestrial Magnetism. There, she met Kent Ford, who had built an advanced spectrometer, a tool used to observe distant space. Together, Vera and Kent started observing stars with unprecedented precision. The focus of her research was galactic dynamics. That's how stars move in galaxies. Up until this point, conventional wisdom said stars closer to a galaxy's center, where matter is denser, should move faster than those on the outskirts. Think of our solar system. Mercury zips around the sun faster than, say, Saturn because of the laws of gravity. But when Vera observed the Andromeda Galaxy, the closest galactic neighbor to our galaxy, the Milky Way, she noticed something off. The stars on the outer edges of the Andromeda Galaxy were moving just as fast as those in the center. According to gravity, with the outer stars orbiting at such a speed, the galaxy should have flown apart. But it didn't. Vera realized there had to be something else, a missing mass, an invisible substance holding everything together. This wasn't a brand new idea. The existence of dark matter had been hypothesized decades earlier by Jan Oort and Fritz Zwicky. But Vera now had the data to prove it. Her discovery was revolutionary. By proving the existence of dark matter, Vera fundamentally changed our understanding of the universe's structure. She showed that the gravitational pull needed to hold galaxies together couldn't be explained by visible matter alone. There was something unseen, accounting for the majority of the universe's mass. Before Vera, scientists thought what we can see or detect, solids, liquid, and gas, was what the universe was made of. But when Vera discovered dark matter, she realized atomic matter is only 5% of what exists. The other 95? Invisible, undetectable, and until Vera, an idea considered completely impossible. Discovering dark matter was a foundation upon which scientists later built theories of dark energy, expanding our concept of the universe to something far larger and more complex than anyone had imagined. Kent, her research partner, himself once said, quote, "I build the instruments and she did the science," crediting Vera as the true driving force behind the discovery. In interviews, Vera often reflected on the isolation she felt as a woman in astronomy. Despite Kent's respect and support, Vera faced constant challenges and dismissals from her male colleagues. In meetings, she was interrupted, ignored. In 1965, Vera became the first woman allowed to use the telescopes at Palomar Observatory in San Diego, California. Women were largely barred from observing at major observatories until Vera broke the glass ceiling. At Palomar, there wasn't even a women's restroom. She famously fixed this problem by cutting a piece of paper into a triangle and taping it on like a skirt to the men's restroom sign. Dark matter finally explained the unexplainable, why galaxies didn't disintegrate. And this discovery? It turned the field of astronomy and physics on its head. But even with this groundbreaking work, Vera didn't get a Nobel Prize. Instead, 44 years later, a Nobel Prize was given to a group of male astronomers, the discoverers of dark energy, an expansion of her work, whose work, unlike many of Vera's findings, was taken seriously when they presented it. Vera's contributions went far beyond the discovery of dark matter. She fought for women's rights in science, helping open doors at observatories and institutions for future generations of female astronomers. So next time you look up at the night sky, remember Vera Rubin. She didn't just observe the universe, she uncovered its hidden truths. Most of what's out there is invisible, undetectable, and was once thought impossible, until Vera pointed her telescope to the sky. Thank you, Vera, for revealing the unseen and helping us understand our universe and beyond. Thank you, Vera. Her story reminds us to follow our own questions, no matter who doubts us. Our next gift is from Big Mama Thornton. Her gift carries a sound. Raw, powerful, unmistakable. Big Mama Thornton's voice helped shape the sound of American rock and roll long before the genre had a name. Her recording of Hound Dog was at the forefront of a musical revolution. But while Elvis became a global icon, her name was nearly erased from the rock and roll story. Willie Mae Thornton was born in 1926 in the rural crossroads town of Ayrton, Alabama. It was the Jim Crow South, where every law, every sidewalk, every front porch step was segregated by design. Willie Mae Thornton got her start singing in the church. Her father was a Baptist preacher and her mother sang in the choir. Then, at 14, her mother died. And yet, Willie Mae continued to sing, loud enough to be noticed.
Gonna feel happy someday.
That same year, a traveling music promoter came through town, Sammy Green. He ran the Hot Harlem Review, a raucous, all-black variety show of singers, dancers, and comedians that crisscrossed the South, performing in juke joints, tent shows, and segregated theaters. He heard Willie Mae sing and knew he had found something special. So she packed a small bag and left Ayrton and the church behind. No formal education, no real safety net, just her voice, her grief, and a place on a tour bus headed into the heart of segregated America. For the next 7 years, she performed almost every night, learning to command a stage, to hold a crowd, to carve out space for herself in a world that wasn't built to let her shine. In the early 1940s, when Willie Mae was in her early 20s, the Hot Harlem Review rolled into Houston. Willie Mae stepped into the next chapter of her life. Houston had become a black music capital, not in name, but in sound. There you could hear blues guitars wailing along Zydeco accordions, gospel choirs harmonizing next to jazz horns, country twang rubbing shoulders with boogie-woogie bass lines. For Willie Mae, it was a musical ecosystem, and she knew she belonged in it. So she stayed. In 1951, she signed with Peacock Records, a small but influential black-owned label that recorded gospel and rhythm and blues out of a makeshift studio in the city. And by then, she wasn't just Willie Mae Thornton. She was Big Mama Thornton. Standing at 6 feet tall, she wore tailored suits, a pocket watch, sometimes a fedora. But it was her voice that truly set her apart. And in 1952, two white songwriters, Jerry Lieber and Mike Stoller, walked into the studio and heard her sing. They weren't prepared. Lieber later said, quote, "She looked like the biggest, baddest, saltiest chick you ever seen. And she had a voice to match." They wanted to write something as bold as she was. And what they came up with was Hound Dog. 12 bars, 3 chords, 1 unforgettable chorus.
You ain't nothing but a hound dog. When snooping around my door.
It wasn't about heartbreak. It wasn't sweet. It was a woman calling out a man who was up to no good. Her version of Hound Dog sold 500,000 copies and spent 14 weeks on the top of the rhythm and blues charts. But it never appeared on the pop charts. At the time, music was segregated just like everything else in America. Black artists were placed on separate charts called race records, later renamed rhythm and blues. And radio stations, record stores, and promoters largely kept those songs from reaching white audiences. So no matter how successful Big Mama was, her hit couldn't cross over into the mainstream. The industry kept the charts and the profits divided by race. She was paid $500 total for her original recording of Hound Dog in 1952. That was a flat fee, no royalties, no residuals. Then, 4 years after Big Mama's release, in 1956, Elvis Presley recorded his version of Hound Dog. It was faster, slicker, tailored for white radio. The single went on to become a global hit and sold over 10 million copies. So while the writers, Jerry Lieber and Mike Stoller, were credited and paid, the performer who helped make it iconic, Big Mama, was left out. And of course, it's common practice for musicians to cover other musicians' songs, but usually they're compensated for it. This wasn't an oversight. It was the business model. The music industry at the time had a system. Black artists created, white artists crossed over. Labels profited by repackaging black sound for white audiences. As Sun Records founder Sam Phillips put it, quote, "If I could find a white man who had the black sound and the black feel, I could make $1 billion. And so he did. He found Elvis. Big Mama kept touring, writing, and performing. One of her original songs, Ball and Chain, was picked up by Janis Joplin in 1967, who idolized her and turned it into a career-defining hit.
Sitting by my window, Big Mama was sitting down looking at the rain. Down by my window, just looking out at the rain.
In this case, Big Mama did own the rights to the song. Yet, she did not initially receive credit or payment and wouldn't for 7 years after Joplin popularized it. It's almost like the pattern is not that hard to see. Big Mama was also trailblazing the lifestyle of the rock stars who would come after her, before the term rock star even existed. She was wild, androgynous, raw. She drank, cursed, wore men's suits, and blew the roof off every room she played in. But no matter how bright she burned, the spotlight always seemed to land on someone else. She died in 1984 in a Los Angeles boarding house at the age of 57. And like so many women who shaped American music, buried in an unmarked grave. And yet, the sound she created echoed far beyond her final performance. From Janis Joplin calling Big Mama her North Star, and Otis Redding channeling Big Mama's church-born gospel blues, to Elvis, Tina Turner, Led Zeppelin, Amy Winehouse, the Alabama Shakes, the list goes on. Artists for generations have stood in her lineage. Thank you, Willie Mae Thornton, for laying the groundwork for generations of rock and roll. For giving the world the gift of your authenticity, your sound, and your songs. Your story inspires us to sing louder, stand taller, and take up the space we all deserve. Big Mama Thornton taught us a valuable lesson. Each of our voices, however different, however loud, can be a force the world can't ignore. Let's get to the next present. A gift from Qianshang Wu. A gift on the atomic scale. Small, but revolutionary. Qianshang Wu was one of the greatest experimental physicists of the 20th century. Her experiment disproved the long-held law of conservation of parity and reshaped modern physics. But when it came time for the Nobel Prize, she was skipped entirely, and her two male colleagues walked away with the honor her experiment made possible. Qianshang Wu was born in 1912 in a small town near Shanghai, China. Her father, a revolutionary and advocate for women's rights, founded a school for girls so she could get an education. By 10, she left home to attend boarding school. By 18, she was studying physics at China's National Central University. But there was no nuclear physics program in China. In 1936, she, on her own, set sail for the US. And she made her way to the University of California, Berkeley. There, she dove into nuclear physics just as the field was exploding. Every physicist wanted to be the first to uncover the secrets of the atom. It was a golden age of discovery, and Qianshang was right in the center of it. She specialized in beta decay, a mysterious process where unstable atoms eject particles in an attempt to stabilize. This changes the number of protons in the nucleus, which can even turn an atom into a completely different element. Then, in 1938, Lise Meitner uncovered nuclear fission across the pond in Europe. Qianshang knew this would change everything. She became one of America's leading experts in fission, as well as beta decay and atomic structure. But being brilliant wasn't enough to get her a job. She was Chinese. She was a woman. And anti-Asian sentiment from the war was rising fast. She followed her husband to the East Coast in 1942, and she did get a job teaching at Smith College, a women's school, but with no research lab, which isn't ideal for an experimental researcher. Then came Princeton. She was offered a position during the war, not out of recognition, but out of necessity. With so many men away fighting, Princeton needed instructors. She was hired during the wartime faculty shortage. Princeton wouldn't allow women to enroll as students for another 26 years in 1968. Then, in 1944, Qiansheng was recruited to join the Manhattan Project. She was one of the few women allowed anywhere near the top tiers of this secret project, and was the only Chinese person on the team. Her presence alone challenged the norms of race and gender in wartime science, forcing colleagues to reckon with the mind they could neither ignore nor diminish. Her assignment? Solve the isotope problem. See, nuclear bombs are made with the element uranium. And uranium has multiple forms. Most aren't fissionable. Only a rare isotope, uranium-235, can sustain chain reactions. The additional step that's needed to create a weapon of mass destruction. Qiansheng's job was to help convert natural uranium into uranium-235. She spent years running experiments, refining techniques, and testing methods that would become essential to building the bomb. Then, in 1945, when the war ended, she returned to her research. She joined Columbia University and began testing a theory from 1933, one that no one had been able to prove. The theory said that during beta decay, atoms don't just spit out a random particle, they also release a specific invisible one to balance out the loss. But Qiansheng built the experiment, calibrated the instruments, and captured the evidence that confirmed the theory matched reality. A missing piece of atomic theory found at last. After showing that invisible particles explained beta decay, she took on an even stranger question. What if the laws of physics changed when you flipped the universe, like looking at it in a mirror? Well, first things first, why would anyone think to flip the universe? Because in physics, symmetry usually means stability. If you flip something, like your reflection in a mirror, most things still behave the same. This idea was called the law of conservation of parity. Think of it like raising your right hand, and your mirror image raises its left. Different directions, same motion, still balanced. It was comforting, elegant, treated as absolute fact, until it wasn't. In the 1950s, two theoretical physicists, Sung-Dao Lee and Chen-Ning Yang, started asking questions. What if parity didn't hold in every case? What if, during beta decay, those tiny particles didn't fly out equally in every direction? What if they all went mostly one way? It would mean something huge. The universe wasn't perfectly symmetrical after all. That nature does have preferences that defy the laws of physics and logic. That nature makes choices. They needed someone to figure out how to test it because they didn't know how. So they called Qiansheng. To take this job, she canceled her first trip back to China in 20 years. She spent 6 months designing a rigorous experiment. Then, just after Christmas in 1956, she proved it. Parity was not conserved. This finding shattered a core principle of physics. It was called one of the most important experiments of the century. And when the Nobel Prize was awarded in 1957 for the finding, it went to the two men who asked her to design and run the experiments. Qiansheng was left out. Again. And what's more, the Chinese Civil War had begun to unfold, and later, the Cultural Revolution. Remember, she had postponed her trip home to work on the parody project, and sadly, her parents were killed in the turmoil before she could plan another trip. She hadn't seen her family since boarding the ship to the US 2 decades before, and now it was too late. But her legacy, that didn't fade. In her lifetime, she earned the National Medal of Science and was the first living scientist to have an asteroid named after her. She was inducted into the National Women's Hall of Fame. And when she died in 1997, her story was still being written, because the discoveries she made, from how to build the bomb to nature still playing favorites, still shape physics today. Thank you, Dr. Qiansheng Wu, not just for proving theories, but for opening doors for those who would follow. Thank you for showing us that the impossible is only impossible until someone like you proves otherwise. Thank you for reminding us that the rules of the universe can always be challenged. She showed us that even the strongest laws in science can fall when someone fearless asks the right questions. Our next gift is from Mileva Maric. The gift of mathematical calculation, proof that women have also been architects of the questions that shape our world. Mileva Maric was Albert Einstein's first wife and a brilliant physicist in her own right. Their letters show she worked alongside him on the math behind his early breakthroughs. But history has only remembered his name. The year is 1875. Mileva Maric was born in what was then the Austro-Hungarian Empire, which is now Serbia. Her brilliant mind set her apart at an early age. While most girls were learning domestic skills, Mileva was all about math and science. Thanks to her forward-thinking father, she was allowed to attend physics lectures, an opportunity rarely extended to girls. But women were only allowed to progress so far in the classrooms in the town she was from, so her family sent her to Switzerland to continue her studies. Fast forward to 1896. Mileva, her intellect so renowned, was the only woman admitted to Zurich's prestigious Swiss Polytechnic Institute for Physics. And it was there that she met Albert. For reference, Albert was initially denied and had to take the entrance exam twice. Mileva and Albert were 2 of only 5 students in the physics department, and they quickly became inseparable. Her meticulous mind complemented his creative one, creating a partnership grounded in curiosity and respect. Of the letters they exchanged while in school, many have been preserved. And they tell a story of 2 classmates in love, spending hundreds of hours together theorizing and poring over equations. Albert was known to skip class, borrow Mileva's notes, and according to multiple sources, reportedly said, quote, "I need my wife. She solves for me all my mathematical problems." By 1900, Mileva was acing most of her coursework, often outscoring all 4 of the other students in the physics cohort, even Albert. But when it came to the final oral exam in 1901, she failed. The male-dominated faculty gave her a low score, while Albert and the 4 other men passed easily. While we may never know what exactly happened during those final exams, a failure was inconsistent with her other grades. And ultimately, she never received her degree because of that failure. Early manuscripts of Albert's papers were initially signed Einstein Merity, Mileva's Hungarian surname. But In later publications of the same papers, her name was edited out. What's more, in one letter written between 1900 and 1901, while they were still in school, Albert wrote to Mileva, quote, "How happy and proud I will be when the two of us together will have brought our work on relative motion to a victorious conclusion." Then came 1905, Albert's so-called miracle year, when he published 5 groundbreaking papers, including the theory of special relativity and the iconic equation E=mc². Mileva and Albert married in 1903, 2 years before the miracle year. They had 2 sons. But while his fame rose globally, hers was eclipsed. Albert began an affair with his cousin, and the marriage deteriorated. They separated in 1914. During the divorce negotiations, Albert promised Mileva a monetary award from any future Nobel Prize he might win. It was an unusual clause for a divorce settlement, sparking widespread speculation. Why would Albert promise a prize he hadn't won yet, unless he knew her contribution helped him earn it? By 1919, Mileva and Albert were divorced. Just before he finally received a Nobel Prize in Physics in 1921, as promised, Albert did give Mileva the Nobel Prize earnings for her and their children. Yet, when Mileva considered revealing her role in this work, Albert wrote her a chilling letter on October 24th, 1925. "You made me laugh when you started threatening me with your recollections. Have you ever considered, even just for a second, that nobody would ever pay attention when someone is completely insignificant? There is nothing else to say to this person but remain modest and silent. This is what I advise you to do." Mileva stayed in Switzerland. She had constant financial difficulties, giving private tutoring sessions to make ends meet while taking care of their sons, one of whom struggled with lifelong illness. She died in 1948. Her contributions almost completely erased from history. Erased until 1987, 39 years later, when the world glimpsed the truth. Long-hidden letters and memories from Albert, Mileva, and their university classmates were published by Albert and Mileva's own son. These documents showed how Mileva's insights were woven into the foundation of Albert's work throughout the entirety of his early career until their divorce. So many letters and first-hand accounts included moments where Albert himself acknowledged her role, calling their work a partnership. And yet, by Albert's own hand and the history books, her role was softened, eventually a mere footnote. To this day, scholars continue to argue about whether or not, or to what extent, Mileva Maric contributed to Albert's work, especially regarding the theory of relativity. But what we do know is this: Mileva Maric was a pioneer. Her story is a testament to the countless brilliant minds whose work was buried in the shadows of others' fame. Behind the man history remembers as the greatest intellect of all time, there was a woman. So next time someone calls Einstein the icon of genius, remember, there was also Mileva, the woman behind the math, his equal in thought, his partner in discovery. A name that must be remembered. Thank you, Mileva, for your brilliance, your resilience, and for forever changing how we understand the universe. Mileva Maric taught us that brilliance doesn't disappear just because history tried to overlook it. Our next gift is from Hilla von Raby. Well, not something literal, something abstract. Hilla von Rehby convinced Solomon Guggenheim to collect the bold, experimental art no one else took seriously. She shaped his entire vision, yet his name is the one on the museum, not hers. Let's go back to May 31st, 1890, in Strasbourg, Germany, the day Hilla was born into a noble family. Her father, a Prussian general. Her art education, elite. As a child, Hilla was surrounded by the arts, and her education emphasized traditional classical art forms. But she wasn't satisfied with the traditionalist paths laid before her. She was curious about something more. She studied art in Paris, Munich, and Berlin, and met avant-garde artists like Jean Arp and Rudolf Bauer along the way. Around 1910, when Hilla was about 20 years old, she became intrigued by non-objective, or what we call abstract art today, a style that wasn't concerned about representing real-world objects. Instead, it focused on pure form, color, and emotion. For Hilla, this was revolutionary, and it opened up the new possibilities for expression. Now let's pause to go over what was happening in the art world at the time. The early 1900s was a period of radical transformation in the art scene. Europe was buzzing with innovation. Modernism was taking hold, and traditional boundaries were being pushed, pulled, and completely obliterated. Movements like Cubism, led by Picasso and Braque, were upending representational art by breaking objects into abstracted forms. Dada artists were rejecting reason and logic in favor of chaos and absurdity. And Surrealism, with its focus on the unconscious mind, was starting to make waves in Paris. But this idea, art as pure, non-representational form rather than depicting real-world objects, was still far from mainstream, especially in the United States, where art collections were dominated by old European masters. Enough context, let's get back to the story. Fast forward to 1927. Hilla comes to the United States. At this point, she's fully captivated by abstract art. The following year, 1928, is when our leading characters finally meet. Hilla was commissioned to paint a portrait of Solomon R. Guggenheim. And here's where things get interesting. When Hilla and Solomon met, it wasn't all business. It was a meeting of the minds. Solomon, a man whose taste leaned toward traditional art, was immediately intrigued by Hilla's ideas about modernism and abstract art. He listened when she talked about the future of art, about the importance of breaking free from past conventions. Hilla didn't just paint a portrait of Solomon. She painted a portrait of an entirely new vision for art, one that Solomon could make a reality. She also shifted Solomon's perspective on what a collection could be. He wasn't just collecting art anymore. He was collecting a movement. Hilla helped Solomon amass works by the most forward-thinking artists of the time, like Kandinsky, Mondrian, and of course, Rudolf Bauer. And it didn't end there. Hilla had a vision for more than just the art. She had a vision for the space that would house it. She didn't want just another stuffy gallery with white walls and little plaques. She wanted the entire building to be a work of art. The vision began taking shape in 1939, when she helped open the collection's first physical space in Manhattan, a temporary location she named the Museum of Non-Objective Painting, a name that reflected the soul of the movement she championed. Not a monument to a single man, but a tribute to a revolutionary idea that art didn't have to represent anything to be meaningful. It could exist in its purest form. Color, shape, emotion. That was the whole point. Fast forward a few years to the early 1940s when Hilla, as the museum's first director, proposed a permanent home for the collection. And she already had someone in mind to design it. Frank Lloyd Wright. A bold choice. Wright wasn't known for museum architecture. In fact, the design he would go on to create, an organic spiral that defied traditional gallery norms, was so radical for its time, critics called it everything from a washing machine to an inverted oatmeal dish. But to Hilla, it was perfect. Wright's design mirrored her belief that art should be experienced, not just simply observed. The flowing upward spiral embodied the same ethos as non-objective painting: movement, freedom, transcendence. It was her philosophy in physical form. But when Solomon Guggenheim passed away in 1949, the tides began to turn. The board, now staffed with his family members and more traditional friends, started rewriting the narrative. Gone was the Museum of Non-Objective Painting. By the time Wright's building finally opened its doors in 1959, the name had changed. The Solomon R. Guggenheim Museum. Which is a little like if the Eiffel Tower was named after Gustav Eiffel's banker instead of, Eiffel, the guy who actually designed it. And it didn't stop at the name. Despite being the intellectual engine behind the entire project for decades, Hilla was excluded from the opening ceremony. The woman who built the Guggenheim, who dreamed it, directed it, and defended it, was erased from its history. But as time passed, scholars and curators began to reckon with the truth. So next time you're walking that spiral ramp, staring up at the skylight, soaking in the swirl of the art and architecture, remember whose dream you're standing in. It wasn't just Solomon Guggenheim's. It was Hilla von Raby's. She saw the future of art, and she actually created a space for it to come alive. Hilla's story teaches us an important lesson. She showed that imagination is a skill, one that can reshape culture if we're willing to defend it. Our final gift today is from Maria Anna Mozart. She so generously gifted us musical inspiration, reminding us that a woman too could be a world-changing musical prodigy. Maria Anna, the older sister of Wolfgang Amadeus Mozart, was a musical prodigy in her own right. She toured Europe, dazzled audiences, and composed original music. But as she grew older, society forced her to give up her craft, leaving her brilliance largely unrecorded. Mozart, the child prodigy, the name synonymous with classical music. But actually, the first Mozart genius wasn't Wolfgang at all. It was his sister, Maria Anna Mozart. Maria Anna, nicknamed Nannerl, was born in 1751, 5 years before her brother Wolfgang. Their father Leopold was a composer, violinist, and ambitious stage dad. And he taught both his children music. By 7, Maria Anna had learned to play the harpsichord, with her 3-year-old brother sitting by her side, learning in their Salzburg home. And then it happened. Leopold noted in Maria Anna's own music notebook that, quote, just before his 5th birthday, on January 26, 1761, Wolfgang learned a minuet and trio in half an hour. And in that moment, Leopold realized he wasn't raising just one prodigy. He had 2. And if you've got 2 prodigies, you don't just keep them in Salzburg, you take them on tour. The Mozart children became Europe's Wunderkinder, the Wonder Children. In 1762, they hit the road. Paris, Vienna, London, 88 cities in total. They played before kings and queens, dazzling audiences everywhere. Maria Anna, poised and precise. Wolfgang, wild and precocious. And here's the thing, diaries from their aristocratic audiences praised them equally. Quote, "His sister's playing is masterly," wrote Count Karl von Zinzendorf in Munich. Their father Leopold bragged in letters, quote, "The world talks of her and marvels at her." Imagine TikTok in the 1700s. These kids would have broken the algorithm. But in London, 1764, the story takes a twist. Leopold fell gravely ill, pausing the tour. Suddenly, the two children, left to their own devices, began to write music. Maria Anna was 13 years old and Wolfgang only 8. What they recorded together is now known as Wolfgang's First Symphony, called K16. Here's where the mystery deepens. Historians still debate. Was Maria Anna simply writing down what her brother dictated, or did they compose it together? Only a fly on the wall would be able to say for certain. What is fact is Maria Anna, with a quill and parchment, wrote the notes down. Or did the older sister, also a music prodigy, collaborate with her 8-year-old brother on its composition? Some scholars, like Carnegie Mellon's Noel Zoller, believe she likely influenced the composition, saying, quote, "I'll bet she suggested some things for the horns, for other parts as well." For other historians, that theory is conservative. It's just as possible they composed the entire symphony together. By 1769, the children's tours had made them famous across Europe. But when Leopold decided it was time to travel again, only one child packed his bags: Wolfgang. By this time, Maria Anna was 18 years old, still a prodigy, but now also a young woman. And that changed everything. At the time, society didn't allow middle-class women to pursue music publicly. Aristocratic women could play in private salons because they played for free, but for a woman to charge money for a public performance was essentially considered prostitution, even if she was only playing a pianoforte. So while Wolfgang continued to dazzle courts and kings, Maria Anna was left behind in Salzburg. Her career was cut off at the very moment it might have flourished. Not because her talent faded, but because she was a woman. And here's what most people don't know. Maria Anna never stopped. She and Wolfgang exchanged letters their whole lives. He mailed her music from abroad. She sent back her own compositions. They critiqued each other's drafts, shaping melodies together across hundreds of miles. And yet, none of her compositions survive. And that's the mystery. Lost or hidden in plain sight under Wolfgang's name. Just like Mileva Marich's physics vanished into her husband's, Albert Einstein's, many women through history have had their brilliance buried because in their time, society wouldn't believe the woman could be the genius. And what happened next would decide which Mozart the world would remember. By the 1780s, the tight bond between the Mozart siblings began to fray. Wolfgang clashed with their father Leopold, refusing to stay in Salzburg, defying his father's control. He moved to Vienna in pursuit of greater fame and fortune. Maria Anna stayed behind. And in the family conflict, she and Wolfgang grew distant. She married in 1783 at the age of 32 to a magistrate and widower with 5 children. She raised his children as her own, and together they had 3 more. Her days, once filled with tours, applause, and letters of music exchanged with her brother, were now spent caring for her father, her husband, and her children. When Wolfgang died in 1791 at just 35, it was Maria Anna who helped his widow sift through his papers and letters to preserve his legacy. And that's the tragedy of Maria Anna Mozart. She was Wolfgang's first duet partner, his first teacher, and perhaps even his lifelong collaborator, and yet she's buried in the footnotes of history. Today, the name Mozart means one person, Wolfgang Amadeus. But in the 1760s, Mozart meant 2 prodigies. And now, after today's lesson, hopefully it will for you, too. Maria Anna's name was lauded in the same diaries, praised in the same letters, applauded in the same halls as her brothers. And then, because of gender, reputation, and the rules of her era,
she became a footnote in the history books.
So next time you hear the name Mozart, remember the sister too. Thank you, Maria Anna Mozart, for the music we'll never hear, and for the brilliance history could never erase. Thank you to all of the incredible pioneers who have come before us. And if you're still with us, thank you for watching and supporting our storytelling that gives credit where it's due. We kindly ask that you like, subscribe, or leave a comment if our show helped teach you some valuable lessons. From all of us at Actually History, happy holidays.